Good morning. Good morning. You're welcome to today's class. Come in. Today's lecture on pharmaceutical calculations, BDT 253. We are still on the topic enumeration and notation, right? Are we done with it? So where did we stop in our last class? Okay, Joe, yes, I think the last thing we discussed was the conversion of the numbers from standard form to ordinary form, and from ordinary form to standard form, and back to what? Ordinary form. I think we dealt extensively with that, so we'll not dwell there forever. We move on to the next thing we have today is operations in what? Standard form. Operations in standard form, where we talk about the basic operations in mathematics. We have the addition, subtraction, division, and multiplication. Addition, subtraction, division, and what? Multiplication. And I remember vividly that I told you that you need to understand the laws of indices before you can handle the operations in what? Standard form. Very, very important. And I advise you that you go back and revise your laws of indices, your secondary school laws of indices. And but I promised you that as we move on, if any particular steps in our calculations has anything to do with laws of indices, I will mention the law and say one or two things there. But I'm not going to teach it as a topic, because we have a lot of things to do what? To cover. This math review itself would have been just come a day class, because for it to be at this level, it is expected that you should know. You see the first topic, that is numbers and numerals. Second topic, enumeration and what? Notations. Then the third topic, rounding, approximation and what? Estimation. Then the fourth topic, ratio, proportion and what? Ratio, proportion and what? Ratio and variation. These first four topics, they are under math review. It's expected for you to carry your YX certificate in your hand with A1 and A2 and all those things. You are supposed to know this. Under normal circumstances, this is supposed to be just a day. Just do a review of all these things, because it's expected that you. But ideal situation will not always be the real situation. So, and we have to deal with the real situation. That's why I'm doing this, and it's drawing us back. But there's no problem. I hope you are learning something from it, especially those that miss this thing in their secondary school. Why I'm not? I don't believe it so much is that some secondary school may not even be exposed to all those things. True of us. Why some may, but they were not serious when they were in their secondary school. But it's okay. Let's continue. Now, we have what? Operations in what?
Standard form.
Standard form. Remember, it's either standard form or what? Exponential notation or what? Scientific what? Notation. Please always remember that. So then we look at addition. Addition, subtraction, multiplication, and what? Division. Okay. Now let's pick an example here to describe what I mean by addition and what subtraction. Sorry about that. Let me silence this phone. Okay. Let me see. Okay, let's look at these examples. I'll just list them, then we'll carry out the operations, in all of them. Okay, look at this one. 3.5. Can you see the board? Is the marker clear? Please help me with a better marker. This one is not writing well. China, you are my board class rep. So each time I come here, make sure you provide my marker and the board is clean. Yeah? So 3.5 times 10 raised to the power what? Don't mind me. 4 plus. Okay. Children, this board is not clean. Okay. Nice one. I like this. So you washing this thing. Wash it. Maybe every what? Every day. Make una allow her to breathe. Allow her to breathe. All right. Let's look at this question. It says 3.5 times what? 3 raised to the power 4 plus 2.0 times 3 raised to the power 2. Now, let's look at this one. 3.6 times 3 raised to the power minus 2 times 2.5 times 3 raised to the power 6. Next one. Number 3. 3.4. We are doing all the operations together. No time. Okay? Times 3 to the power what? 3 minus 2.1 times 3 to the power 2. Number 4. 8.2 times 3 to the power 2 divided by 4.6 times 3 to the power minus 3. Now, let's solve this. Let's start with addition. Now we have on the board 3.5 times 3 to the power 4 plus 2.0 times 3 to the power 2. Now, whenever you are solving any operations in addition and subtraction, they have the same the same steps. You take the same steps in solving what? Addition and what? Subtraction. And the addition and subtraction are related, while multiplication and what? Division are somehow what? Related. Now let's look at addition so you understand what I'm talking about. Now, look at addition. Please do not make the mistake. The operation between, look up. What I'm going to do now is technical. So look up. The operation between this 3 point, in number 1, the operation between 3.5 and 10 raised to the power 4 is what? Multiplication. Are we together? The same way here, the operation between 2.0 and 3 raised to the power 2 is what? Multiplication. Now, in between them we have what? Addition. So, using your normal factorization process, you factor out the common what? The common what? The common what? Factor. Are we together? Once you bring it out, the question is what? Solved. Just as this thing is, let's put this in symbol. This thing is the certain are saying it looks like, watch out, 3.5x plus what? 2.0 what? Y. True or false? True or false? True or false? Or let's assume here is also what? X. Okay, let's say here is also what? X. We know because they have the same x is here, you will simply do what? Add them, right? But why must you add them? The basic rule here is what? Factorize what? Bring out the common factor, which is what? X, right? You have what? 3.5, right? Plus what? 2.0. This is the basic step here. And if you add this and this, if you add what is in the bracket, you have what? 5.5 times what is outside? Times x, which is what? 5.5 what? X. Are we together? Now looking at this now, you know, you just okay, x is here, add it, but this is what actually happens. That's why when what you have here is y, you cannot do it like that. You still have to do what? Look for a common factor between the two of them. Two of us, by looking at let's assume here is 4. You say, okay, the common factor here is what? 2, right? You bring out 2. You have what? 2s plus what? Plus what? Plus what? Y. Not 1. Who said 1? It's y. Now, with that at the back of our mind, anytime you are giving addition and subtraction, your mission is to create common factor. And you cannot manipulate the coefficient easily. You can manipulate the index part, this part easily. Remember our decimal what? Movement. True or false? You can manipulate here easily. And you can manipulate here and here to have the same what? Value. Am I communicating? You can manipulate this and this to have what? The same value. And once you're able to manipulate this and this, you can add and you can do what? Subtract. So anything you are doing is to ensure that this power here and this power here are the same thing. Once you want to add or do what? Subtract. Ensure that the power here and the power here are what? Equal. If you're able to do it, you follow this step and solve the what? The problem. Now let's do what I just said now. Yeah. Let's do what I just said now. As you can see here, you have 3.5. Please, anything I said here you are not following, please don't keep quiet. Please draw me back immediately. Not when I'm done. You tell me, sir, I didn't understand anything. I won't talk to you. As I'm moving from one step to another step, know when I'm getting to another step. Call my what? Attention. I have moved up to 5 steps here now. I know when I called my attention, so I'll assume that you understood what I've been saying since. Now, taking a look at this now. You have 3.5 times 10 to the power 4 plus 2.0 times 10 to the power 2. Now, you can either work on this to bring it down to what? 2. Or you work on this to bring it up to what? 4. If you work on this, you play along using the decimal movement to bring this thing down to what? 2. For them to be equal. So either way, you get the answer will be what? Correct. Is that how you work on this? Bring it down to 2. That means decimal point here will move. True or false? Yes. True or false? Then they are equal. You can now add up. Or you work on this, bring it up to what? 4. Now let's do that. If you understood our last lecture, bringing this thing down and bringing this up, I don't think it's a big deal. If you understood what we discussed in our last class. Now, let's do it again. I think this thing is of no use for us, right? Oh, yeah, discard it. Now, let's do what I just said now. And it's a kind of refreshing our memory about what we did in our last class. Now, take a good look. Let's work with the first term. We have 3.5 times 10 square. So, which one? Just tell me, people should tell me where you want us to work on. Any of them is okay. Where? First one. First one is what? Okay, we should do what? To 2, right? Good. Now let's reduce this to 2. remember this is the what? Stable form, right? True or false? Now let's. So what can we do? What can we do to fall to this power 4 to bring it down to what? 2. That means we want to do what? Reduce it. And if you reduce it, decimal movement and the what happened in power are always what? Opposite, right? So if you want to reduce this, we will move. We'll go 2 decimal movements, right? Yes. Now, if we go 2 decimal, which direction? Reduction. It should what? Right direction, right? Because we are reducing. They should what? Opposite. Negative and opposite and what? Negative what? Charge. True or false? I'm bringing it to physics. So you appreciate what you are doing. Opposite and opposite do what? Attract. And negative do what? Okay. Now let's look at this now. So the decimal movement to here should be what? To the what? Right. Now let's do it. This will now become what? This will do what? Move. 1, what? 2. True or false? So we have 350 times what? 3 square what? 2. This and this are equal. I hope you know. They're the same thing. They are what? The same thing. This one is what? The stable form. You should leave your answer in case you are solving. But this and this are the same thing. They have the same value. Point check, the same thing. Are we together? Now let's work on this one. This is 2 point what? 0 times what? 3 square what? 2. You can't do it again here again. It's same thing, right? You have succeeded in putting this in now in the same what? Power. So you do what now? Add up. Remember our rule of adding decimals. You align the what? Decimal point. So let's go. We have 350. Where is the decimal point here? 350 point what? 0. Are we together? Are we together? Yeah. Good. Now, before I do that, let me go to factorization so you understand what's happening. This now is setting as saying 350 times 3 square what? 2 plus what? Plus what? 2.0 times 3 square what? 2. What is the common factor here? 34. Bring it out, okay? Then you have 350 plus what? 2.0 times what? Then work on this one. If you work on this, we have aligned with the decimals. We have 350.0 plus what? Decimal should be here, right? The point. You have 2, 0. We did this in our last lesson, right? So I don't think that one is an issue. We have what? 0. We have what? 2, 5, 3. So we have 352 times 3 square. Bring out this 3 square 2 times 3 square 2. This is the answer. Now, if you want to bring it, at first you take it back to the what? Stable form, right? You have your what? There will be decimal movement, right? Yes. Move how many times? 2. So as it's moving to the left, the power is what? Increasing. So you have 1, 2. You add 2 here because 4. So we have 3.52 times 3 square what? 4. So this is the what? The answer when you add this to this. You can punch your calculator to confirm, but don't depend on the rest, just to confirm 1 or 2 things. But that's the answer. Maybe you are writing the thing as a essay question. State your steps, but try to do what? Confirm your answers, okay? With your what? Calculator. Because whatever you do must be the same thing with your what? At least you can just use your calculator to do what? Confirm your what? Answers. But this is the answer, following the rule. Now, if you want us now, we can also work on the what? We can increase this, okay? Hello, are we together? Yes. We can do what? Increase this. If you are done, or do I start immediately? I'll give you like 1 minute to do that. Put this in now so we can. After 1 minute, I'll clean it off. Are you not done? Okay. Any question? Okay. Where? Which one? Okay. Okay, I said that, from the what we stated in our last class, where after our series of proof, we now came down to what? A statement, right? Where we say that the decimal movement, direction of decimal movement is always opposite to the changes in the magnitude of the what? Power. If the, by opposite, I mean, if the direction of the decimal point, of the decimal movement is to the left, the power will do what? Increase. If the direction of the decimal movement is to the right, the power will do what? Decrease. So if you have one decimal movement to the right, power will do what? Decrease by what? 1. If you have two decimal movement to the right, the power will decrease by what? 2. Now if you have decimal movement to the left, power will do what? Increase by 1 and vice versa. Are we done? Are we done? All right. Let's work on the second term of the question. The second term. Let's work on the second term. By working on second term, the second term is what? 2.0 times x power what? 2. So work on the second time by doing what? Increasing it, right? Yeah. Yes. Our goal is to increase the what? Yeah. Now let's go. We have 3.5 times x power what? 4 times what? Sorry, plus what? 2.0 times x power what? 2. This one is already in the. Okay. How I know that we're going to decrease the power?
Like when we increase it.
It depends on, but you know when to increase, and you know what happens to the decimal point that will cause you an increase. You know now that if the decimal point moves to the left, you do what? You increase the power, right? Yeah. If you move to the right, you do what? Decrease the power. You can choose anyone you want to work on. The target is that these two power must be what? The same thing. Go and call the ZLA. Whether you want to work on this one, anyone want to work on this. I'm working on two of them just to prove to you that you can work on any of them and get the same answer. That's why I want to work on this again. The target is to do what? Let them be the same power. If you decide to work on this one, that means you have to do what? Reduce it, right? To be what? 2. If you want to work on this one, that means you have to do what? Increase it to be what? To 4. So that the two of them will be what? Equal. You are not to decide. The basic thing is to know the direction of the decimal movement and what it will cost to the what? Power. Once you know that one, you are good to go. Are you with me? I just did this, but I want to do this one now to show you that anyone you work on will give you the same answer. Your mission is that the two power should be what? Equal. That's your mission. Now let's work on this one. This one is 10 times 10 to the power 4. 10 times 10 to the power 4. So we want to increase this 2 to 4. Now let's bring it out. You have what? 2.0 times what? Times 10 to the power what? 2. Now, for us to get to 4, we need 2 decimal movement. 3 of us. We have 2, we have 3, and what? 4. Now, are we increasing or decreasing? We are increasing. So if you are increasing the power, what direction would the decimal point move? To the left. So now, let's move. 1, 2. Decimal point will be here, right? You fill up here with what? 0. So we are left with what? 0.02 times 3 to the power 4. So now what we are now adding is this. 3.5 times 3 to the power what? 4 plus what? 0.02 times 3 to the power what? 4. That's what you are adding. The common factor is what? You will do what? Bring it out. You have what? Inside the bracket. 3.5 plus what? Times what? So let's add this. Let's align the decimal point and solve this. So we have what? 5. Because of these 2 decimal places, let's put what here? 0. Plus what? 0.02. Add up. We have what? 2, 5, 3. So we have, bring this in down. 3.5 2 times 10 to the power 4. Are they the same thing? So anyone you work on, you get the same what? Answer. You just decide to, anyone you want to work on, just most important thing is to understand the rule behind this. After our series of proof in our last lecture, that last statement, that the direction of decimal movement is always opposite to the what? Changes in the magnitude of the what? Power, period. Which means that if the decimal movement is to the what? Left, then the power will do what? Increase. If it is to the what? Right, the power will do what? Decrease. Once you understand this, you don't have any issue in any of this. So we are this addition, this subtraction follow the same what? Rule. Okay? Subtraction follow the same rule. The only difference is that here you'll be doing what? Subtracting, that's all. The only difference is that here you'll be doing what? Subtracting. But you follow the same rule by ensuring that the 2 of them have the same what? Power. So if they are done, we'll do what? Number 3 is what? Subtraction. We'll do number 3.
Yes.
If you like on your own, try this subtraction on your own, okay? 3.5, do 3.5 times 10 to the power 4 minus what? On your own. You use it to practice. Test it this side, test it this side, and confirm. But we are going to solve this one now. So to know if you are there after solving, punch your calculator to confirm with your what? Calculator. To ensure that, to know whether you are on the same page with your calculator. If there's any discrepancy, let me know. Then we'll find out where the problem came from. Let me see. I think after this scientific notation, we are done with enumeration and what? Notations. The only thing is we talk about it I'll just write out some numbers to test whether you know how to arrange, how to detect the decimal number that are the magnitude of the decimal numbers, the one that is higher than the other, the one that is greater than the other, and the one that is less than the what? The other. I think that is the only thing we need to do under this topic. Then if there's time, just solve 1 or 2 general practical questions that have to do with percentage. This one is not an abstract percentage, just general real life scenario with medications. I think that's what we may have to do next. I will call it a day or a whatever in this topic. Then we'll move over to the next one. Are you done? Can we continue?
Yes.
Good. Now let's solve the what? Subtraction. Let's look at number what?
Number 3.
Number 2 is multiplication. We are doing addition, subtraction. We are following this order. I just listed what we will work on, okay? But we are following what? This order, okay? So now, let's look at this. Following the same pattern, let's look at this one has no money. Okay. Let's look at 3.4 times what? 3 to the power what? 3 minus what?
2.2.
2.1 times 3 to the power what? 2. Now let's work on this. Of course, as usual, our mission is to do what? Ensure that the 2 powers are what? Equal. We can we can choose to decrease, reduce this power, so we have 3 raised to power what? 2. We can decide to increase this one. I'll just solve one. Use one for your what? Practice what? Example. Now let's reduce this to get what? 3 raised to power 2. Now let's bring it down. We have what? 3.4 times 3 raised to power what? 3. Now look at it now. This can only decrease by 1 to get 3 raised to power 2. And as the power decreases, decimal movement will be to what? Will be to what?
To the right.
To the right, right?
Yeah.
Good. So now, so if this power comes down to 2, we have 1 decimal movement, but to the what? Right. So this will move to here. So we have something like this. 34.0 times what? 3 raised to power what? 2. So we can now subtract. So we have 34.0 times 3 raised to power what? 2 minus what? 2.1 times 3 raised to power what? 2. Let's bring out the what? The common factor, which is 3 raised to power what? 2. So we have something like this. Inside the bracket, we have 34.0 minus what? 2.1. Outside the bracket, we have times 3 raised to power what? 2. So let's align this. We have 34.0 minus what? Decimal point should be here, right? 1 should be here, then 2 should come where? Here. Are you following? Good. So we have, let's go. So what can we do here now? You borrow 1 here. If you borrow 1 here, you add it here, it becomes what?
Yeah.
How is it 10? Why is it 10? You do what? Explain. Good. 1 times 10 is what? Plus 0 is what? 10 minus 1 is what?
9.
Good. Now here, what's remaining here? 3. 3 minus 2 is what?
1.
You have what here?
3.
So you have 31.9 times 3 raised to power what? 2. I don't like this. You move the what? Decimal point to here to come immediately after the first what? Digit. Are we together?
Yes.
So we have what? 3.19 times 3 raised to power what? As it's moving to the left, the power will do what?
Increase.
So we have times 3 raised to power what? 3. You can leave this as 3.2. There's no problem. Okay?
3 point.
Yes. You can appropriate that 9. Okay? No, you can run that you can run it up. It's okay, no problem. So, but the basic is that it's 3.19 times 3 raised to power what? 3. So that's the answer. If you subtract 2.1 from where? 3.4. So on your own, you can try. You can increase this to be what? 3 raised to power 3 and do the thing. You get the same answer. All things being equal. Okay. Now, if we are done, I want us to go to, we move with the speed of light. I think I've laid foundation for this, so I need to move fast. We go to multiplication. Multiplication. Is that what? Round up. It's 3.2. That is 3.19, right?
When you round
Now look at it, leave it as 31.9 times 3 is 2. If you want to round up, you need to be
32
32
times 3 raised to power 2, but you can't leave it at 32. This step here, 3.2. Are we together? 3.2 times 3 raised to power what? 3. Let's go to multiplication. Can I clean?
Yeah.
All right. Please, if you watch, I don't want anybody to have any excuse to fail this course. Level of understanding and retention must not be what? The same. Okay? Level of understanding and multiplication must not be the same. That's why I record my lectures. Every day I send the link. You can see it and keep a blind eye. There's no problem. And before the school management, this is what I will say. Because when they start begging, add mark, I will say, I will not add mark. Because I did everything possible for you to do what? Pass. What you can say, if 49, you never back on one mark. But you didn't go for. Are we together?
Yes.
You didn't go for. I don't know no I boom lie. But I made you go to the end. You could give him from the beginning. Age more for merchant record edit send there. If we are a blind eye, in a class understand there. You you don't want to go and listen to it. You never blind eye. Continue. I know what I'm doing. Every day, they post here. Some people see this man, they post. No problem, man, they post here stick. So far in that group, you will give me a poor. But I can post here steady. This is what I do. All the schools I teach. All my WhatsApp group, all the schools I teach, all the classes, I have. If you go to my phone, what you see, menti about Kanko. I share it all of them. In another way. In share that school. When they resume, I'm going to school farm card. I will also share it in your platform. It's again. It's all again now. We look at again name TikTok. On a chani. If 49. Can you give one mark? So jokes apart, take it seriously. That's what I'm making. Understand that people's understanding are not what? It's not your fault. Hello, I'm playing peace. Okay, that's fair. Even about another fugi. She's saving you now. She's playing. You will not see to me now. You are joking. Understanding are not what this. It's not your fault. Hello, it's not what. As a teacher, I understand that understanding differ. It's not your fault. Don't feel so bad or feel so demoralized that Nanya Kaimala. Forget that thing. You cannot have the gift differ. Hello, gift what? Yes. Oh, when there are people that their brain may not be that sharp, but when it comes to things that have to do with putting things, know that they are good there. If we only that normal or one or her own what? As everybody must not be what? Perfect. Now, but since you are here, you need to do what? Measure up. What do you do? A thing like this is what will help you. Hello? Cool down, get your note and listen to it. Make your note at your leisure time when you're what? Relax. There are people not here. Yeah, they don't understand what I'm saying. It's not their fault. There are people that put here that has already concluded. Let this man finish. Let me go to this person to teach me this thing very well. It's not your fault. I understand it happens. But what happens? The water is to understand who you are. Man, know who thyself. If you know yourself, you know how to handle your what? Situation. And you may even be what? You may be shocked. You may be shocked that because you know what you don't have and look for a way to help yourself, you may be shocked that in the exam you don't have super brain name with A. True of us. You know what the same A. You may even yourself get herself because they may relax. You do what? 100% is for everybody. Hello. 100% is for who?
Everybody.
Also, would you bring something where you 101? True of us. No matter the type of brain you have here, you can never have what? Score 100. Highest in 100. And which you that is not that have a lower IQ can still make that 100. What will help you is this. After class, what else do I do to make up, to measure up? You put more effort than that one that has what? Higher what? IQ. That's the only difference. You put more what? Effort. You may even put down more effort and come out the best in class. It happens. It happens steady. So don't see yourself because maybe first year you feel that you manage to escape. You are one of your legs was nearly caught. You won't be at the jacket and kill to school and enter second year. Don't be discouraged. Don't be discouraged. What matters is this: come to class, do what you are asked to do. What? Do. Simple. Let's continue. Now, let's look at what? Multiplication. Remember what I said? Okay, let me write that for. Number 2 says 3.6. Now, on I yes I go. Use gear jaja. I need a virgin marker. Now 3.6 times what? 3 square what? Minus 2, right? Are we together? Times what? What is the origin of this noise now? 2.5 times what? 3 square what? 6. Now look at it. Hope it's clear. Can you see it? Good. Now look at this. Please, this has no business with the other rule. Hope you know. It has no business with the other rule. Basic law of indices will help you here. Okay? Yes. Basic law of multiplication and indices. Simple. If you understand law of indices, you can solve this. So basic multiplication law and indices is one to do what? Help you here. Now let's look at this. Let's look at this. If you have your calculator, if this is where to be in theory exam, where you need to show your work, you see that your calculator alone cannot save you. You must state what you did. Now, but calculator can still help you in a way. But if you're not using calculator at all, you should try your best to do what? Eliminate this decimal point first. Okay? If you eliminate the decimal points, there will be decimal movement. True of us. Now, if you eliminate the decimal point, now there will be decimal movement to where? Right or right? And if the decimal point moves to what? Right. This will do what? It will do what? Reduce, right? Yes. And become what? Minus what?
1.
Minus 3. Minus 2 or minus 1? Minus 2 minus 1, which one is greater? Some places say minus 2. Minus 2 and minus 1, which one is greater?
Minus 1.
Minus 1 is greater. So if you move from here to here to the right, for this to be what? That means you subtract 1 from here, right? So we have minus 2 minus 1, which is what? Minus 3. Minus 2 minus 1 is what? Minus 3. Minus addition, which one is more powerful? This thing always deals with addition most of the times. Watch out. This times this is what? Minus. This plus this is what? Is it minus or plus? Okay, let's make it practical. Hello? Let's make it practical. Minus 2 plus minus 1 is what? Minus 3. Minus what? Minus 1 plus minus 2 is what? Minus what? Once these two are together, this will always do what? Eat it up. Hello? But if this is that together, 1 minus minus 2, it becomes what? Minus times minus is what?
Plus.
Minus times minus is what? Plus. Are we together? Now, if you have, but if this thing is greater, let's assume we have minus 2 plus. For this plus to clear this minus, the number that has this plus must be what? Greater than the one that has what? Minus. So we have minus 2 plus what? But the value will come down, 3 of us. Minus 2 plus 8 is what? 6. Which is plus 6, right? These are basic mathematical operation that deals with people. Hey, when I was in primary 1, this dealt with me. Primary 2. He dealt with me. Which one is that? Is minus. Okay, let me make it practical, okay? If we have minus 2 times minus times 7 is what? Times plus 7 is what? It's minus 14. But you have minus 2 times minus 7 is what? 14. Is it clear? Is it clear? Good. Now, these markers are not right. What's going on here? I asked for a virgin marker. You are giving me something else. I'm going to go here. What's going on? Maybe we should go to the secretary and calculate marker. Okay, till September. Okay, I think she's trying to control it, so you don't abuse it. But even at that, all right, let's go. Hello. Hello, look up. Now, with that, I think I've done justice to this. Now, let's look at this now. We say that, we are not using calculator here. So my target is to do what? I want to clear this decimal point so I can easily multiply without issues, okay? I want to clear this decimal point. I can see that I can deal with it, but if I start it now, it may confuse some people. Aligning the decimal point. So to be on the safe side, do what? Clear it. Now, if I want to clear this now, here becomes what? 36, right? Yes. Times 3 to the power what? The decimal movement to the what? Right. This will do what? Decrease. We can times 3 to the power what? It's minus 3 now. Because we have minus 1 minus what? Minus 2 minus 1 is what? Minus 3. Because this one, remember, if you say we are reducing, that means we're doing what? Subtracting 1 from it, 3 of us. Because the decimal movement is only just 1. So you subtract 1 from that 1, 3 of us, that's minus 2. And minus 2 minus 1 is what? Minus 3. So that's why here should be what? Minus what? 3. Then times, look at this one. We do the same thing here. Here is what? 25, right? Times what? So we subtract 1. We do the same thing with this here, 3 of us, because we move like this. We move to the what? Right. So we subtract 1 from 6. So 6 minus 1 is what? 5. So here is what? 5. Now we have gotten something that will help us to do this. So what you need to do is this: using law of indices and the simple multiplication. We do what? Let's go. Let's bring like terms, right? Let's shift them together so you can easily work on them. The one that has power is what? We have what? 36 times what? 25 times what? Times what? 3 to power what? Can you see the board? Yes. Good. So we have what? So let's do this. 26 times 36 times 25 is what? Is it 900? Not sure.
900.
Because 5 times 36 is what? 5 times 6 is 30. 5 times 6 is 30. 30 times 30. 5 times 6 is 30. 5 times 30 is 900. So it was. Did you understand what I did now?
Yes.
5 times 6 is 30. 30 times the remaining 5 is what?
That's like 100.
Look at it now. Hello, are we together?
Yes.
Are we look at it? Are we together?
Yes.
Good. Now we have 5 times 6 is what? Don't worry. Let me split it again. 6. 5 times 6 is what? 30. Is it clear? I understand. Number is still playing with you guys. Start playing with numbers with time. Only 1 or 2 people are managing to start playing with numbers here. I want you to start playing with numbers. Play with numbers so numbers will stop playing with you. Look at it here. Simple. Split this into 2, right? 6 times 6 is what? 36. 5 times 5 is what? 25. This is what? 30. This is what? 30. This is what? 900. Now let's go. So I just confirmed what she pressed anyway. Now it's what? 900, right? So it's what? 900. Now we have what? Hey, boy, I don't know. I thought you were following. I said 36 times what? 25. Instead of wasting your time trying to, okay, this time, this, just simply, you know that this thing is, root of this is what? 6. 6, right? Root of this is 6, right? Here I'm getting 6. So there are 2 6. 6 is here, right? This is what? 5. This times this is what? Each of yourself, just may what?
3 times 3.
This is very fast. Answer one. Let's continue. Thank you. Before I confuse somebody. Eva. Hello. Someone asked an intelligent question. Ask your boy open up a 4. It's what?
23.
Eva, we get it. 6. I mean, it's talking about 8 times 3. Okay, what do you mean? Eva, get 8 times 3. Eva, get it.
6 and 4.
Okay, 6 and 4, 8 and 3. Anyone is okay. You know that, hello, here is what? 30, here is what? 20, 600. Honorable. Hello, remember the watch? There's something I told you in our either first class, hello. I told you, listen carefully. I told you something in our first lecture, either first or second lecture. I told you, if you are doing calculation without calculator, stop creating large numbers. Break it down. If the head will just come out, you just see it. Once you break it down, bam. I didn't even need to do it. Once I broke it down, I have already known what happened here. That this time this will give me 30, and this time this will give me 20. And in cheap the 0 now they behind 2 and 3. Now two zeros. 6 times
3 times
2 is 6. I want to bring back 2 zeros, 600. Play with numbers. And numbers will fear you. Play with numbers, it will fear you. Now, maybe when someone just asks, What did you see? Under 1 minute, you outside. Hey, computer brain. It's practice. I want computer brain in here. You just know how to go around number. You can't look at now punch it. The person will just when you go from these serious competitions, even now, who live in now? You don't need calculator. Few seconds, you know what? How? It's a practice. Know your numbers. Know their place values. Know how to deal with them. Then you get your answer. Now, hello, look at this thing. Look at this. Now we have this. We have now right now. Using law of indices here. What do we now do here? Law of indices. Time what? At 3 for what? Minus 3 what? Plus 5. Good. Plus what? 5. Law of indices, right?
Yes.
They have common base.
Yes.
You put the common base. What join the common base? Or if what join the common base is multiplication, then the power should be added, right? That's law of indices. Now we have this. So it said I say 900 times what? Minus 2. Good, thank you. 3 power what? 2. 3 power what? 2. Now let's bring this in down. We have what? 1, right? We are moving, right? We want the decimal point to come here, right? Right? So we move. 1, 2. We are moving to what? Left, right? So we add how many on the power? 2. We move 2 times to the left. So we add 2 there, right? We have what? 9.0 times 3 power what? 4. Does it make sense? Does it make sense? What is going on here? Yes. If you move, if the DM is 4 times, if the DM is 4 times, you either add 4 or subtract 4, depending on the direction of the what? DM. So if the DM, you know what DM, right? Decimal movements. Now, if the DM is to the left and the 4 times to the left, you add 4 in the what? Power. If the DM is 4 times to the what? If you have 4 DMs to the what? Right, you subtract what from the power. If you have 4 DMs to the right, you do what to the power? Subtract 4 from the power. Simple. That's basic simple rule. I hope we will not confuse this with Mendelian inheritance. Because it looks like that, right? Yes, please, let's not confuse. Anyway, I believe you know that one. Now, so that's the answer. 9.0 times 6 power what? Hello? So 9.0 times 3 power what? 4. That's the answer. Yeah.
Can the answer be 9.0 times 10?
No, just leave it at 9.0.
Assuming in an exam, you don't 9.0.
Why are you adding 0? I'll mark it. Don't leave it there. Don't try it. Why?
Indices are 1 and 2. We have minus 3 here. But in addition and subtraction.
Okay, remember what I told you, that when you come to multiplication and addition, you follow the law of what? Indices for the powers. Law of indices say that Why you follow it? Remember? Hello? Hello? We said that for the law of indices, that a raised y raised to power a times y raised to power what? B is equal to what? Y raised to power a plus what? B. This is the index law. One of the laws of what? Indices. We call it what? Multiplication law of indices. Am I communicating? Now, if you come here, this takes that form. Hello?
Yeah.
Look at it, the same base, and the power is there. So that's why this will follow what? That's that law. But there is no indices law, law. We don't have raised to power y plus y raised to power b. This thing doesn't follow this law. Okay? All together. So that's why you do, but you can factorize easily. That's why you made the power to be what? The same. So you can factorize out. Okay? That's what happened in what? Subtraction and what? Addition. Now, there's also another law of indices that says that division law. It says that y raised to power a divided by what? Y raised to power b. Of course, you know that this is certain as saying y raised to power a over what? True or false? Is equal to what? Y raised to power a minus what? B. This is the division law of indices. Now, when you want to carry out the operation of division in standard form, you get to a point where you have 3 raised to power divided by now what? 3 raised to power. True or false? This law will now come in. That's why I said that you handle these powers when you are talking about multiplication and division. You use laws of indices to handle these powers. But it's not the same thing with what? In what? Subtraction and what? Addition. In subtraction and addition, your target is to make sure that the powers are what? The same thing. Are we together? Now with that, I think we are done with this. Let's solve. You can try this multiplication with any of these things here on your own and see what it will give you. Now let's look at division. Let's look at what? Division. Which one is that? It's 9.0 times 34. You know that? Hello. Shh. Can you put chicken and liver? Mama, do you? Let's correct it now. Can I correct it? I like long, yeah. So when you keep quiet. Then after you got the same question again. Before. What's going on? Are you distracted? Are you sure? Someone asked that question now. I told them no problem. That you can leave the way you know. It becomes an issue. Hello? It becomes an issue if I'm specific. Maybe if I give an instruction on decimal place to give it, that's when it becomes an issue for you. What you want to ask a question?
Okay, I'll put you what.
Good. Now let's handle what? Division. Chinanya. Now look at this. We have what? Hello, one house please. We have 8.2. No, I never.
Sorry, that number one, that 3.5 times 0 is power 4. Because like when it comes to solving for addition and subtraction, is it possible for the power to be minus?
Power.
Like for instance, we use 3.5 times 0 is power minus 4. Plus 2.0 then 0 is power 2.
Yes. If you want, you can still make this one to come down to what? Minus 4. If you like, you still bring up minus 4 to come back to what? Now, what can you do? Let me now take your question back to you. What if you have 3 raised to the power minus 4 and 3 raised to the power 2? What do you think you can do to 3 raised to the power minus 6 to make it become 3 raised to the power 2?
Your decimal movement should move to the...
Before you know where it will move,
And you
you ask. Tell me what you should add there. What you should do to it first.
What you want for minus
If you want to move 3 raised to the power minus 4 to 3 raised to the power 2, what would you do to that 3 raised to the power minus 4? Add what?
You add
2. If you add 2, it becomes 3 raised to the power minus 2.
From 4 to
Minus 4
minus 4
to 2.
to 2. You remove 6.
If you remove 6, it becomes
Minus 4 minus 6.
if you remove 6, it becomes minus 10. So what do you do? Add 6. 4 from that 6 we neutralize this to 0. The remaining 2 will break it up to what? 2. So you add 6. And if you want to add 6, what you are adding now. So what the direction would the movement be on the coefficients? To the what?
Yes.
Because you're adding what? 6, right? You're adding, right? Now that means we have how many dm? 6 dms to the what?
Left.
To the what? Left, because you're adding 6 in the power. If you do it, let's assume here is minus. You start moving 1 up to 6. Then it's now the same thing you add. Okay? As of you may get 2.252, and in all you may approximate you come down to simply what? 2.0. Am I communicating? So just try out all these things. Is what is that?
That you have 10 times 10 raised to the power minus 3.
Okay.
Times 10 raised to the power 5.
This one minus 3 times what?
Times 10 raised to the power 5.
Okay.
Now, the power we add.
Yes.
Okay, what if you have 10 raised to the power minus 3 divided by 10 raised to the power 5?
That's what we want to do now.
You subtract.
That's where we want to do now. Yeah. Of course, I have only stated the rule here, so you should know what happened there. But we want to use this number 4 to show it. Okay, that's where we want to look at. Now we have 8.2 times 10 raised to the power what? 2 divided by what?
4 times 10 minus 3.
Times 10 raised to the power what?
Minus 3.
Minus 3. Now, remember, you handle the coefficients together, okay? And handle the what? The index what? Together, true or false? So that's what we do. So now, if you want to handle them, what you now do? This set, are you aware that this is setting as saying 8.2 times 10 to the power what? 2 over what? 4.6 times 10 to the power what? Minus 3. You can split it and have something like this. Play with numbers, split it and have something like this. 8.2 over what? 4.6 times 10 to the power what? Minus 2 over what? Are they something?
Yes.
Are they something? Yes. Of course they are. You are split again now. Where two pass. So coefficient no each now. Then the index part no each. So you can apply the law of indices here now and divide this one outrightly. Hello? If you are not using calculator, you can shift this thing again. If you're not using calculator, you can shift this. It will become what? 82, right?
Yes.
Times 10 to the power what? Is it 3?
Yes.
Good. Is it 3?
Yes.
To the right.
No.
DM to the right. If you move to the right, what the power will do what?
Decrease.
So he has what? 10 to the power what? 1. Hello? Over what? 46 times what? Minus what? 4. Because you are moving to the what? Right. You reduce the what? Power by 1. True or false? It becomes minus 4. Minus what? 4. If we guess where math is now. If we that you don't do so, just simply divide 82 by 46, you get what?
So I have a question.
Ask.
Sir, is there any multiplication and division that you must minus?
You say what?
Like division and multiplication. Okay, this is minus element and gas.
Minus where?
Like Iyi-Enu maybe say the decimal movement to the right minus 1. Also for 1 can minus. Okay, just click on the decimal. What is the minus?
Chineke na-akọ nnọọ ka onye ịkọgide ịkọka ya ofu ihe. You are distracted. No, for real, you are distracted. If I see a student that is distracted, I know. Or they are coherent. Or color. Or do what is going on? This is what we have been doing here since I've been following. You started asking questions I don't understand. What is your issue? Let me understand your problem now. What's wrong with you know there's a difference between you don't understand, you don't know this. You are trying to catch up and you are distracted. You move to a room, go for after you see a different note on the board, you become more confused. Okay, you wanted to ask a question?
Yes.
Ask, feel free.
Can we do 4.6 times 10 raised to the power minus 3 divided by 8.6 times 10 raised to the power 2?
Perfect, you can do it, yes. Come on, the power guy know there. You can do it. The power guy know there, true of us. Now, let's look at this thing now. We have 8.2, right? Let me confirm whether this is 8.2. What I made mistake. Okay, it's 8.2. I'm right. Now, so we can now divide 82 by what? 46. And subtract this one. Let's go. 82 by 46 is what? Okay, you want to bring it down? It's okay. It's okay. You can also go straight. Okay. 82 divided by 46 is what? 1 remember what? 1.6. Okay, you want us to use calculator?
Okay.
2 minus 4. Listen carefully. Hello. We know it's 1, right? You can only get 146 as a whole number there, right? So 2 minus 46 is what? 36, right? Times 10 is what? Remember that it's 36 now. Times 10 is what? Divided by 46. How many 46 can we find in 360? Around 8 or 7 something. 7 46 as a whole number. So remember is what? For that 46 times 7, just subtract it from the 360. You what is remaining?
38.
Huh? 38 times 10 again is what? 380. That divided by 46 is what? And that's 7, right?
No, 8.
Is it 8? Is it 8? At the end, we have 8 what again?
8.26.
Okay, we can leave it like this, okay? What's remaining behind is 2, right?
Yes.
You can also make it 1.8. There's no problem. It's something, okay? But let's go. Times what? Law of infinity will not take place here. What's that? 1 minus what? Watch out. What happened here now? Good. 1 what? Minus 4. It will become what?
1 plus 4.
The answer is what?
1.785.
Is it true?
That's a better method, you don't complete it. That's a better method, you don't complete it.
You don't answer what?
How you divided that?
Which one? Hello? Wait. Some people say that they didn't understand what I did. Okay, what's the problem? Okay, division is the problem. A 2 divided by 46 is the problem. Do it yourself. But it's okay. I even sign it. Now let's look at this. This is what I signed. Okay, I think this is okay. Okay, now let's sum. Can I clean this now? Yes. I can, right? Good. So let me clean it. Don't worry. Let me do that. Another method. How? I don't understand. It's very simple. Very, very simple. Very, very simple. We say our target is to do what? We want to divide what? By what? What's that? It's 5 now. It's 5. Hello? Please look up. Those that did not understand, some people say that they didn't understand what this one I did with a calculator. Please look up, please. I will not do it. You can do it. Can you see it now? Where do I stand now? If I stand there, can you see it? Okay. Okay, we have what? 82 over what? Times what? Over what? We are okay with this side, right? Yes, sir. We are okay with this side, right? Yes. So let's look at what coefficient. As I saw you, I don't understand this. Look up now. So we have what? We said the first to do is to do what? Divide. If you hear this long story in Ano, 82 divided by 46 is simple. How many 46 can we find inside 82 as a whole number? How many? 1. Now, how do you know the one that is remaining? Subtract that 46 from 86. 46 from 82. You have what? You have what? 36. You asking me now. You have what? So the remainder is what? So you have 1. Remainder means the one that remains that we cannot divide to get a whole number. That's remainder, right? So we have here 1. And because of that remainder there, okay. And because that remainder, which is 36, is not up to 46. Here, because you put what here? Are we together? Because up by angle fraction now. It will make up the fractional part of it. So we have what? Points here. So that remainder, you multiply by the base you are working on. This base, we are in base what? 10. 36 times 10 is what? 360. You continue dividing. So 360, good morning. 360 divided by what? 46. The same way again, how many 46 can we find as a whole number? In 360. 7, are you sure? Chinas, are you with us? If you multiply, okay, that means let's try 7. So 7 times 46 is what? 6 times 6 is 7 is what? 42. Aria, 6 times 7 is what? 42, right? Good. 7 times 4 is what? 28. 28 plus 4 is what? 32. It's not true. So 360 minus 32 is what? Let's go. 8. 5 minus 2, 3. So we have 38. So if 46 divide 360, we have what? 7. Remember what? 38. So we put down that 7. Multiply the remainder by what? By 10, which is the base. We have what? 380. We have already established that 360 contains 746. So 380 will not also be up to 8 what? 46, right? So we still maintain what? 7 here. True of us? 360. Are you sure?
Yes.
Okay, wait. Okay, 20 here, 20 plus 58. Okay, good. 58 is up to, so we call it what? 8. Remember, if you add, we have, hello, are we together? Are we together? 38 remained here, right? Right? So, what is meant to, what you want to add here now to make it here 8 is what? 23 of us. This is 360. 38 remain, right? Yes. You add 20, it becomes what? 58, right? Yes. Now 46. If you remove 58, 46 from 58, what will be remaining? 380. It's 12 now. It's not 12. Who is lost? Who is lost?
It's even more complicated than that other one.
It's not. It's not. You know they are even between. Hello. Please, let's know something. That they are even between as something is complicated that I don't understand something. Are you aware? There are two different things. If you understand what you have been doing here, this is the easiest method to take. If you understand what you have been doing here since. Listen. Instead of going back again and start dividing 380 by 46, you have already divided it by what? You have already divided 360 by 46 and got what? 7. Remember what? 8. What you remember what? That's 8. What is the difference between 380 and 360? 20. Sit up. That know how to sit in class. 380. Sit up. Like a student. Sit well. Then you listen. I say you have already divided 360 by what? 46 and got what? 7. Remember what? 8. Now, instead of going back again and start looking for what again to use to divide 380 again, you already built up something here. You are building upon what you have already built before. You have built that 360 here. If you divide it by 46, you have what? 7. Remember what?
88.
Remember what? 38. And what give us this is what? 360. And what you want to divide what? 380 by the same 7. No need going back again. Simply to do what? Add this thing here. Add the what is on top, which is 20, right? To here. You have what?
58.
We have what? 50 what? 8. How many 46 and 58? 1. Add to this 7. We have what? 8. What is the meaning? What is 8 as and what?
It's 12.
Is it 12?
Yes.
Is it 12?
Yes, sir.
12, good. 12 is the meaning. So that means in summary, you have 380 divided by 46 what? 8 remember what? 12. Each of us has they're not problem with it. You want to go back again and start dividing 380. And run away from this again. You start dividing again 380 by what? 46. So you already built something here. They don't give you build. That there are 7 whole numbers. 746 as the whole number in 360. There's only 746 inside what? 360. And what to divide 380 by the same what? 7. Why are you going back again? Simply build on what you have already what? Built and continue your work. But if you are not so smart to do that way, no problem. Cancel feature, then go back again and start from where? 380. It's okay. It's not wrong. Okay, it's not wrong. But this is the simplest way to go about it. Remember this. You can easily punch a calculator and do this, but it's good to know how to do this in Maca Now, especially that some of you that say what I also want, that say anything I'm doing it on purpose. Especially some of you that say want to write jam tomorrow. Take it or leave it. Some of you will still want to write jam, even though you are preparing for what? Diet entry. You still have to. You still do what? Want to what? Write jam. You know how to. It's not magic. These things are what you practice, and it become part of you. Now, if you do that, now we have what? That 380 divided by 7 is what? Sorry, 46 is what? 8 remainder what? 12. So we are within that 8. We want to know what is behind it here. So how many multiplied by the base you have what? 120, right? So divide by what? 46. How many 46 can we have in 120 as a whole number?
3.
We have 3, right? Sorry, 2. Yeah, 2. We have 2 because 2 times 46 is what? 96, right? So we have 2 here. 3 of us at this level. I don't need to continue again because I can leave my distance at 1.78 or 1.8. So let me stop wasting time here. I can stop here, okay? Then multiply by what? 3 square what? 1 minus what? Minus 4. So this is what? Let's leave this. Let's put this. Let me leave it at 2 decimal places. But if you do 1.8, I'll mark it. It's okay. Times 8 square what? 5. 1 point. This is not 1.78 though, because you are not dealing with tens. Okay, it's 1.7 what? 8. Okay, 1.78. Once is it is any digit after the decimal point. You don't call it as 7 like this. You don't say 1.78 is wrong. It's 1.78. Now we have 1.78 times 3 square what? 5. Yeah. Yes, I said it now. Huh? Please leave it at least 2 is okay. Don't start creating long thing. At least 2 is okay. Base normally should be 1. But if you do 1.7, I'll mark it. It's okay. They're not playing with it, okay? Good. Now, that's this. That's for the last question on this. So, you see, using law of it, this we are wasting our time here is just because, not wasting it, it's not a waste. It's because of trying to divide without what? Calculator. It's important to learn these things. Learn these things. It's very, very important. Okay? Those people that build this calculator, I don't know. They are trying, but it's affecting us here in one way or the other. It's good to know how to operate 2 of them. In case anyone that you are faced with, you can do what? Do it comfortably. There are people that without calculator, they cannot do anything again. 3 of us.
Yes.
There are people. What if you are in an examination hall? You are about to stop working. And the exam you are writing, are you aware that you don't borrow in exam hall? If you go to a standard exam, it's wrong. Forget this thing you are doing here. You don't do such thing. In exam hall, you don't talk to anybody. You don't borrow anything from exam hall. Come with what you need. On a more serious note. That's a standard exam. You don't borrow anything. If you know everything you need, what is your problem these days? No, seriously, it's becoming something else. What is going on? I'm talking here, you people are just giggling like What's the problem? Now, what if you're in an examination hall? In such an exam, you don't need to even talk to anybody. The calculator you so much trust. You went out on. You go. That's the end. Nabano, Misa, go that end. So please, please. And are you also aware? Are you also aware that if you're in a jam jam examination, are you aware that if you know these skills, are you aware that you be faster than someone who punch calculator? Some questions in JAM don't need calculator. No, not some questions. JAM questions don't need calculator. Their answers don't need calculator. JAM give you answers. You'll be there. You use calculator to start creating bogus numbers. Someone that understand the whole thing will know that their answers, their options don't need calculator to solve them. By the time you need a calculator to punch 8. Each of the punch 8, we punch just 6. And you make mistake, the answer is there. JAM is designed in such a way that if you make a mistake, the answer is in the option. You take it and be going. I am when you're going to say, hey, you only 120, and that's half. What's going on? So please, the point I'm making is this: please develop yourself in that line. Now we are done with operations, right?
Yes.
Please solve more questions on your own. What is going on here?
Calculator that na the computer. Magic calculator.
Then iwe nwajochi calculator let me say to an assistant. Heat awag. Hello. Hello. Go na AC. He's an emegi. Please when you go. You know AC na do heat and emegi. And no one drop of sweat ever, one drop. So please, and once you lose concentration, once you are confused. If HM or B. So please develop yourself, build your confidence. Use calculator. You can use calculator to confirm what they are doing, but not to depend on it. Please don't depend on it. It's not good. It's not good. Now, hello. Now let's look at. Now I want to list. I think. What's time? So I should go now, right? Okay, your hunger is pushing me. Your hunger is pushing me. Your hunger is pushing me. Now, I want to list some decimal numbers. So you tell me which of them is greater and which of them is let's just do it sharp. No time. Just sharp. Now, but what Kalia? And it's true. I know something. There were 3 categories of people over the weekend. There are people that leave the school and travel out over the weekend. That's category A. And if you look at that category A, AI and AII. Let me list. Hello, let me list the categories first. And category A. Yeah, those that carry their bag and leave the school over the weekend. When category B, those that were in the school, but they were not actually in school. When category C, those that were in school and they were actually in what school. Now, this category C, those that were in school and they were actually in school are those that Saturday after morning devotion, they go to the hostel, wash their clothes, carry their books, either sit down one corner and study. And those categories C, if they come to class on Monday, they are always calm and quiet. They are loaded. A lot of things, as you are teaching, they are, listen carefully. I'm telling you, I am being real with you now. As they are, if they sit down, a lot of things are going on in their mind. They are trying to align what they read with what he is teaching. They are a lot are going on in their brain. That's category C. Then category B, though that we are in school, but they were not actually in school. He said that they were in school playing, parabolated, or went out, come back in the evening. Where they're going, I don't know. But they are not actually in school. If they come, they have some level of confusion.
Yes.
Take it or leave it. They have some level of what? Confusion. Their entropy, at least Noebe, at least all this, the entropy of to obele. If even they are not coordinated. They are trying to coordinate. They are not ready for that class. Then category A, Bundi Pula disappear from school. Where they are water at all. Now, in that category A, AI Bundi na befa. When if the important hajj, maybe na mama choice for her, but no we ya choice Jesus. Confusion on the abukwa. Hello. Confusion there about directed confusion in a way because only had them and don't only would only hey but I have no choice. India when nakota. I was always if you had a period na afak na come on open nobody ya mami akporia o kale na eba ya na ewuti ya. Go. Then category AII. Bunijalefu uncle. My friend actually come on their friend. The simple truth is school. The simple truth with category AII. Mono na school. But they have no idea where they went to. The basic thing is that so whatever they went to do, because of course whatever they went out to do, even some self their roommate wouldn't even know. Someone said that they want to collect free food. Now, if on there, water, and how can they deal with the aftermath of where they went to? Either they are chatting, how was the? They are confused. They are still being operated by where they went to. They are still being controlled. Obuno nwoke ka aje ifo aka na sigara baby have fun and I cut all ya let's get on. Then after the lectures if we are come on ga achoba ogbafo efozi anya oje na akụ ofia. Hello. Ifuzi anya. Iche mu nwiri ifuzi anya. Ifuzi anya ebe na akali oyisi. Flower. All flower na akajicha flower ndi eba. Hello. Imandia. How I didn't confused for the next 4 days? That's it confused. Then, Bidozi Jabudi Ja. If you're not brother. Oh, why you can name with distinction though. If you know you're which means on no 5 years ever what woman. Oh, was it within 3 to seek a money whereby distinction. If you know you're so please know what you are doing here. Each time I stand in front of you and look at your face, I see those categories. I divide the class into these categories. But you wouldn't know. I've already divided the class into that category. Oh yeah, they went on water. Oh, we connected. Hello, shh. Guess. Let me give you an instance. Oh, connected. Ofo say some they will tell them this place you went. Am I even supposed to do this? Won't you see me as say, hey, if I say, hey, they have some group, hey, I'm a bago. Then some group will be like, you sure now? Nah. When you come where? And that group had different groups. Lecture is going on. What is going on? Why would she or he understand? When they go, Chineke gear. Emily Kwanuchuku, Chuku, Ijanga, or Chineke boy. Conscious, boy and girl, and conscience, spirituality, and I'm taking it for them. Conscious, that's a vision. No. Oh, when the doses are on with no, you're just controlling Ghana strategy. So you have different categories. Where do you belong to? Don't forget why you are here. Once nyemela. Why you are here. Hello? Every human being will take responsibility for his actions and what? Inactions. I will take responsibility for mine, okay? You take for your what? Yours. But above all, don't forget why you are here. That's where Jabu. I don't understand the see, I'm saying this now, we are joking, playing. But these things, here have reality. Remember, I was once like you. So I know all these things. But the point I'm making is this, please get what? Focused. Get what? Focused. Because at the end, what matters for as far as you are staying here, you are in this school at this point in time. At the end, what stuff are you made of? What did you fill yourself with? Those things distract you. How I say now then they ask question, how far should be how far? Now them they ask question. Now them they go for it. You don't even need to invite them. Hello? Now them going to go to their different friends group and the school group to look for those. Hello? To look for those ndiga me on a weekend. They are like that. Come in and please don't forget why you're here, please. It's very important. Do you know why I said this? I think because I noticed that some of you are here, but you're not here. So we are here. I'm not discouraging you from asking questions. Ask that your question, no problem. But I must tell you the truth. Some of you are here, but it's been a Monday na carry you. If Monday, Monday na you. So ndị anọ na category C, biko jisi n'ike. Hello.
Thank you, sir.
Ndị category C, jisi n'ike. Unu ga-eri ụgwọ ọrụ unu. Ndị category B, I advise you join category, you upgrade to category C, ndị category B. Because they draw careful. You see na B, by A. Do you know why? I say now, if you don't stand up for anything, you do what? You fall for what? Enter because you fall for it. You stand up for something. Stand up for what? Something better. If you don't stand up for something, there's something you stand up for. You fall for what? Anything I call. It's true. When you are gallivanting, that's when you now realize that now whenever get because you are not occupied with something. You want a program over the weekend. You have no program for the weekend. That's where I need. Oh, that's how you stay without doing anything. You'll be bored. Because type on out Nigeria or that. Some will follow their classmates and jam Some will follow this because when they have one for the weekend, they become bored. When you are doing nothing, you become what? Bored. Every girl go by. It may be let's go to Crunches. It may be let's just go and come back. And from there, because you are doing nothing, you hook up there. Hook up. I mean, from there, interactions start coming, right? And a phone. Numbers will be exchanged. Hello, numbers will be exchanged. Then from there, see that all of friends, just friends. And from just friends, you get t-shirts. You bet polo ne luaba. You bet polo luaba. Aki ara. And because ndị mekana ya bụ ndị category B. Because how want to get kai for good batanya kai for bata. Apụọ. Be coming down now. Category B go apụọ magolu ejegolu yiri ya face. We chalu ni that this chalu ni chalu abatakwa. Biko nu. See, onwere ihe megide. Hello. Onwere ihe megide n'ụwa. Ka ime ya avoid n'ụwa. Ọ ga na-adịlele. Ode cast and bias the solid name. Ọ ga na-adị. Mana point m na-eme bụ nke ọ bụ na ị na-eme, don't forget why you are what? Yeah. Mee ka ndị bụ mara ebe ị na-eje. Una ga-enwe ya. Una ga-enwe ya. Mommy, achọrọ m ije na nke mee ka Now let's go. Let's look at this the decimal. 1, 2. You should be able to do what? Know the one that is what? Greater than what? The other. Hello? You may be tested in this regard, okay? Yes. Maybe here now 1.2 to 3. Anyway, you can easily know. Let me write another one. Okay, which is is what? Greater or greatest? Or in value, right? Yes. Good. Follow by what? 1.844. Follow by what? 1.233. It's simple now, right?
Yes.
Now, look at this one. 4.1. Look at this one. What? No, you may just be asked to get the one that has the highest value, simple. Or the one that has the lowest value, simple. Highest value going to count. Just you may be asked to like in the last year, just ask them to circle the decimal with the highest value in the group. The second one highest value. Yeah. Then the one look at this one. 0.05, 0.5, 0.115. Highest is what? Heroes, you don't put 0.1 for highest. Are you going to be? Carry on, come on, carry on. Don't lie, just tell me to be sincere. Carry on. Seeking on. Aisha. But everyone this see natural itiku na eu. I say natural. Now, okay, get the which are the highest value? 0. what? Good. 0.5 had the highest value. Followed by what?
0.05.
Good. Huh? 0.115. Yeah, but handwrite and again. Who says 0.5? Kevin. Seeking on. Say. Now, followed by what? 0.15. Good. Last one is what? 0.05. So this one has the highest value, followed by this. No, this one, followed by this, then followed by what? Okay, good. Listen. Hello, please. Listen, hello, please. If you hear those one that has the decimal point, you want to know the one that has that is higher. Please don't forget their place values, okay? Don't forget their place values. Look at this one. This is 0.5. After the decimal point, you have a tenth, right? This 5 non a tenth. Even though I can't on a tenth up here, this one in a tenth. But this 5 is bigger than this one. Yes. But I can't add a tenth at all. What do you need? Hundreds. Tenths, hundreds. So this one is even out of the game. No, these are the ones that can confuse you. Both of them are in tenth, but this 5 is greater than what? So this one is highest. Followed by this before you do what? Now look at this one. You have 4.1, 4.01, 4.001. All of them have the same whole number, right? 4. Now go down to the decimal. After the decimal point, what next? What next here?
0.
So this compare the see. Hello, if you want to know the one that is greater than the other, compare their place values. If they have the same place value, look at the face value of those in the same place value. The one that has the highest face value among those of the same place value is higher than the other. Look at this one. This is 4, equal, right? Now let's consider the after point is tenth. Tenth. 0 is here. 0 is here. So now compare the two of them. After point, 0 is here. 0 is here. Go to hundreds. 1 is here. 0 is here. So can. So this greater is what? This followed by what? This and what? This. Chinaya. Listen again that way. But on I do my konya what if on water. Okay. Assuming what? 4 point what? Is a good aware. Okay, someone asked a very, very intelligent question. She asked, what if we have 4 point what? Oh yeah, let's answer her. Basically, they have the same words, the same numbers, right? Good. Now here, we have 1, 0 here. 4.1 is the highest. Compare with what? Followed by what? 4 by what? 0.5. Because even though this 5 and this are hundreds, the face value of this is greater than this. This is 5 and this is what? 1. So this is greater than this. So this followed by this, and this. No, ask, quickly. Ask.
Is it, are you going to the way the question will come, is it to pick one particular one answer or to arrange it?
Last year, I can change to anything. What matters is for you to understand. Hello, I'm based on what I asked last year. What I asked last year, I just listed about 5 series of like this now. This may form number 1. And that's another group, like here may be number 1. We have this group. This may be another group. This may be another what? Group. Maybe the title, maybe 5 questions, you may ask, circle the decimal with the highest value in each of the group of numbers. So it's just circle the highest value there. In some other form, you may ask, circle the what? The lowest value among this series of the group of decimals. So if you ask now to choose, circle the least, the lowest value, what is the lowest value here?
1.233.
Here, encore. Lowest value.
0.05.
Here, encore. Ma.
In this type of question, are we going to do approximation? Because
What? You're not appropriating anything. I'm going to give you something. I was not going to give you grammar.
sorry, it's
Wait,
only answer.
who was you telling you to shut up? Give her the shut up. Okay, joke. Now, but even if I ask you to arrange them, you can arrange them. Once you know the basic principle. Any question? Questo che è vero. Yeah, Rafa. Kezi, ever come on. Why do you go there? Ola, Chai. Any question? I think we okay. I think wait. We are done with this topic, okay? And anything we see here is just practical questions. So I think I will stop here.
Thank you, sir.
Allow her now.
I thought you said we will do example with practical.
But people say that you are tired now. What do you say? Hello. Listen carefully. In our next class, tomorrow, I will just solve 1 or 2 practical questions. Maybe just pick randomly in each of these 2 practical oriented questions. Solve them. Then after that, I'll give you tomorrow. From Wednesday, we'll start quiz on this.
This one.
Wednesday.
From Wednesday, Emanuela, you do your own tomorrow on numbers and numerals, please. Tomorrow, hello, shh. Tomorrow, by God's grace, we conclude with Emanuela on numbers and numerals. Then I will solve 1 or 2 questions on this. We enter another topic tomorrow. Then from Wednesday, as I enter here, mkpọọ gị ịkwụrụ ọtọ ịbịa na board. Ị na-aza nna amaka gị. All right, see you tomorrow.